This video is going to go over how to name ternary ionic compounds. So grab your notes, and then also a copy of the polyatomic ions and a periodic table will be helpful as well. You can label your periodic table with oxidation numbers. Up first, let's talk about what it means if something is a ternary ionic compound. So something is ternary if it has 3 or more elements. So a compound with 3 or more elements. And including in that, you will see a polyatomic ion. So if you see a compound and it contains a polyatomic ion, one of the things from this list, that means you are going to be naming using the ternary ionic system. So let's talk about what a polyatomic ion is. So the prefix poly means many, and atomic relating to atoms, and it's all going to make up an ion. So what we see is an ion that has many different atoms in it. For example, phosphite right here. Polyatomic, many atoms. We have phosphorus and oxygen, but all of these group together, PO3, so 1 phosphorus, 3 oxygen, they group together to form an ion, and that is the ion's charge. So all of these numbers off to the side right there are crucial because that's the charge of your polyatomic ion. We define it as an ion made of many atoms that are covalently bonded together. Don't let that covalent part throw you off. Polyatomic ions still make up ionic compounds, but within the polyatomic ion itself, we do see covalent bonding. But really just know that polyatomic ions will be involved in ionic bonding because they are an ion. All right, let's get started doing some practice and learning how to go from name to formula and formula to name. So up first, name to formula. It's going to be very similar to what we have previously done. We just have to watch for our polyatomic ions now. Okay, we see aluminum. We know aluminum is Al, and we see sulfate. So sulfate is on our list. And sulfate right here is SO4 2-. So 2-, that's the oxidation number. So we are going to write down AlSO4. Now for the oxidation numbers. Aluminum on the periodic table is 3+, and sulfate we just saw was 2-. So this one, the oxidation number we get from the periodic table, and for the polyatomic ion, we use whatever it gives us on the list. Same thing for writing the formula. We're just going to crisscross those charges and make them subscripts. However, if a number comes outside of the polyatomic ion, we do have to write it in parentheses. So this 3 is going to go out here, and this 2 will go here. So we have Al2, and we're going to put our polyatomic ion in parentheses, and then the 3 goes outside of it. And you can see why it's really helpful that we put that in parentheses. Otherwise, we'd have a 4 next to a 3, and it would look like 43. So we want to put that in parentheses. And that's it for name to formula. It's not too bad. Let's do another one. This one has iron in it. We've got a Roman numeral because it's polyvalent. Roman numeral just tells us the oxidation number. So we have iron. And then we have phosphate. So phosphate is going to be a polyatomic ion on our list. Phosphate is right here. PO4 3-. So for the oxidation numbers, iron is a 3+. It tells us from the Roman numeral. Phosphate on the list was 3-. These are going to crisscross. So we would have Fe3 and then PO4 3. However, just like before in an ionic compound, we always want to simplify our subscripts. So if we have a ratio of 3 to 3, that's really a ratio of 1 to 1. So we can just write FePO4 instead. And that is our final answer. So we simplified those subscripts, 3 to 3 to just 1 to 1, so we don't even have to write them. All right, moving on, formula to name. Just like we did before, we are going to name each little piece. The different part is that if it ends with a polyatomic ion, do not change the ending. Typically, we've been changing the ending to IDE. Do not do that if there's a polyatomic ion. So if the formula ends with a polyatomic ion, don't change the ending. For example, MgCrO4. Mg is magnesium. And now we need to find CrO4. CrO4 is on our list, and it's right here, and its name is chromate. So all we're gonna do is write down chromate. We don't have to change the ending or anything. So this one is magnesium chromate. Very, very simple. Up next, we have CO3, PO3. So cobalt is a transition metal, which means it's polyvalent. So because of that, our answer has to have a Roman numeral. That way we know which specific cobalt we're talking about. So there's cobalt, and the other part of it was PO3, and PO3 is right here, and that's phosphite. So we know CO, that is cobalt. Let's leave some room for a Roman numeral, and then PO3 is phosphite. Now we have to figure out what that Roman numeral is. We know that there are 3 cobalts and 2 phosphites. We're gonna have to use the charge of phosphite to figure out what the charge of cobalt will be. So phosphite, we have 2 of these groups. Each of these have a 3- charge, which means the total negative charge would be 6-. We have to even that out with cobalt. We know there are 3 cobalts, and it has to come out to be a 6+ charge. We need to balance those out, cancel them out. So if there is a 6+ charge and we have 3 different cobalts here, then what we need to do would be divide by 3. So 6 divided by 3, each of these are going to be a 2 positive charge, which means our Roman numeral is going to be 2. It's a lot of work to get the Roman numeral, but keep in mind this time, instead of finding the charge on the periodic table for that, we are just finding it using our list. All right, you're gonna see 4 questions right here. Go ahead and try to answer these. So we've got a name, turn it into a formula, turn it to a name, go to formula, and then a question. Pause the video and answer these questions. All right, up first, we have ammonium chlorate. Those are both polyatomic ions. Let's find them on our list. Ammonium is here, and then chlorate is here. So let's jot those down. We also need to crisscross our charges. Ammonium is a plus, chlorate is a minus. So after we crisscross, we don't have any subscripts. So our final answer would be NH4ClO3. That is ammonium chlorate. Next, we're going to write the name for NaClO2. Na is sodium. ClO2, if we look on our list, is chlorite. So our final answer for number 2 would be sodium chlorite. Number 3, ammonium sulfide. You've not seen one that ends in IDE yet. Ammonium is a polyatomic ion. It's the same one we used here, NH4, 1+. But sulfide, that tells us we have the element sulfur. So it ends in IDE. That tells us we have the element. Sulfur has a 2- charge. So we'll just now crisscross the charges. We need to put NH4 in parentheses because that 2 is going to be outside it, and then S. So ammonium sulfide is NH4S. Last question. Does the ending of a polyatomic ion change when it forms a compound? No, it does not. You have to leave it like that. For example, if we were looking at this one again, cobalt 2 phosphite, we have to leave phosphite alone because that ending tells us the specific polyatomic ion. If we changed it to phosphide, IDE, that would tell us we had the element phosphorus instead. So watch your endings very carefully. Okay, you now know what a ternary ionic compound is and how to write the name or formula for the compounds.